What's up, study heads? It's Daniel, aka SAT Prep Tutor, and today we are going to solve 4 of the hardest SAT math questions that I've seen in a long time that are showing up on the new digital practice test. These all come from Linear Test 8, and they are going to be very, very tough. So let's see if we can solve them together. Before we do, I highly recommend that you check out Cracked. Cracked has all of the things that you need to succeed on the SAT, including study plans, an amazing Discord server, some of the smartest tutors and creators I have ever met, a million questions. It feels like their question bank is that big, and they have great practice tests as well. I love Cracked. I think you will too, so definitely check out the link below. With that said, let's get started on some of these ridiculous math problems together.
Question 24. Triangles PQR and LMN are graphed in the XY plane. Triangle PQR has vertices PQ and R, of course, at 4, 5, 4, 7, and 6, 5, respectively. Triangle LMN has vertices LM and N at 4, 5, 4, 7 plus K, and 6 plus K, 5, respectively. What? Where K is a positive constant. If the measure of angle Q is T degrees, what's the measure of angle N? Let's start by just graphing these points in an XY plane. It's going to help me visualize what's going on. There's point P right at 4, 5, Q above it at 4, 7, and R at 6, 5. Great to label as you go, and please use the scratch paper you're given on the test. Clearly, this is a right triangle, and I know the lengths of the legs, 2 and 2. Right from 5 to 7 is 2, from 4 to 6 is 2. That makes this an isosceles right triangle, a 45, 45, 90 right triangle to be exact. Anytime I have that, I go to the reference sheet to find that the side length ratio is x root 2. That is on the reference sheet for you. That makes QR 2 root 2 as the hypotenuse, which we're not really looking to solve here, but I do know that my angles will be 45 and 45. Now I'm going to draw the new triangle, and I don't know what the value of K is, but I'm still going to put my points L, M, and N. Notice that this triangle looks very similar. It even shares an angle. We'll learn that it is similar in a second, but right now the looks are very, very alike. What do I know about this triangle? Well, I know the distance from L to M is 2 plus whatever that K value is, and I know the distance from L to N is 2 plus K as well. That means that length LM is equal to length LN, regardless of what that K value is. That means we once again have an isosceles right triangle, 45, 45, 90, because the legs are the same. In this case, these are going to have 45 and 45 degree angles too, which means angle M and angle N are both 45, just like angle Q and R. Angle T is going to be 45, therefore, which means the measure of angle N is going to be 90 minus 45, which is also 45 degrees. Which answer choice gives me that? Well, we still haven't found K, and A, B, and D are all using K, which isn't actually going to work for us here. What is going to work for us here is 90 minus 45. So let's get rid of D, let's get rid of B and A, and the best answer is C. You absolutely nailed it. We are one problem down. Great work and happy studying. Question number 26. In the given equation, C is a positive constant. Which of the following is one of the solutions to the given equation? Now, this is a constants question, which I usually hate. And I hate it pretty here too. It's a hard question. How am I going to even contemplate solving this question? Well, I'm looking for the solution, which means x equals. And I notice I have these clunky denominators, so let's just get those onto one side. Let's move that entire fraction over. I'll get x squared minus c squared over the square root of x squared minus c squared is equal to 39. What do I do from there? Well, I want to get rid of that denominator, so I'm going to use strategy of squaring both sides. Why in the world would I square both sides here? If I do that, I get that square root out of the denominator. And what will I be left with? I'll be left with x squared minus c squared squared, or x squared minus c squared times x squared minus c squared, over x squared minus c squared. Ooh, and that equals 39 squared. Now I notice here that I can actually cancel out two of those terms. So all I have left is x squared minus c squared equals 39 squared. I'm solving a solution, so I want the x by itself. I'll add the c squared over to the other side, doesn't matter which order. And then when I take the square root of a square, I'm going to have to account for the positive and the negative roots. Plus or minus 39 squared plus c squared. What answer choice looks like that? Well, we have a minus square root c squared plus 39 squared, and answer choice D. You nailed it. Great work and happy studying. New question time. Let's look at 27. The perimeter of an equilateral triangle is 852 centimeters. The three vertices of the triangle lie on a circle. The radius of the circle is w root 3 centimeters. What is the value of w? Let's just first draw this triangle. And it's an equilateral triangle, which means all of the sides are the same and all of the angles are 60 degrees. It's going to come in handy on this one. Now we're looking for the radius. The radius is a point from the center, which I'm drawing now, to any point on the outside of the circle. I've just drawn three equivalent radii, and that's formed something for us. Now, instead of one equilateral triangle, I have three isosceles triangles. They're isosceles because that is how radii work. Radii are always equal. Now, I'm going to make something really cool here. I'm going to create a right triangle. And what is that right triangle going to be? Well, I'm cutting that angle in half, which means one of them is 30, one of them is 30 degrees. And because the other angle is a 90, that means that my top angle has to be 60. This is a special right triangle, a 30, 60, 90 right triangle. This is huge for success. Now, I know that each of the equilateral sides is going to be 852 divided by 3, which is 284. And if I cut that in half, because I'm taking half of that triangle from the bottom, I'm going to get a side length of 142. Now, I'm going to set up my x root 3, 2x relationship for a 30, 60, 90, which I can find on the SAT reference sheet, thank goodness. The side opposite the 60 is my x root 3 side, which means 142 is my x root 3 side, but I hate that. How does that even make any sense? Well, it's really the same as saying 142 root 3 over root 3, which is kind of cool. And that means that my x is going to be even different than that. Less than that, of course, 142 over root 3, because I take away that root 3. That means my 2x side is going to be 248 over root 3, 284 over root 3, I should say. Ooh, Daniel, be careful. Now I'm going to multiply that by root 3 over 3 so I can get the denominator in the right place. I'll get 284 over 3 root 3, which is my correct answer. Plug that in and you'll get the question right. Great work and happy studying. And our final question of the day. 27. The quadratic function g models the depth in meters below the surface of the water of a seal t minutes after the seal entered the water during a dive. The function estimates that the seal reached its maximum depth of positive 302.4 meters 6 minutes after it entered the water, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? Let's start by graphing the seal's journey. He starts at the surface at time equals 0, 0, 0, and then his maximum depth at 6 minutes, 6,302.4. I know that doesn't look like a 3, and every time I try to fix it, it gets worse. Then he resurfaces at 12 minutes, 0 feet, because his depth is now 0. And it's parabola. Great. Now we can use Desmos, plug in these 3 points, and we can get the equation of the parabola. But I'm going to show you the mathematical way to do it too, just in case you ever need that. Y equals a times x minus h squared plus k is our vertex form. And anytime we have the vertex form, I can plug in the vertex, which I know, the maximum or the minimum. X minus 6 squared minus 302.4 because it's below the surface. Remember to be very careful with that. Now, I'm going to plug in one of my points. I could plug in 0, 0 or 12, 0. I'm going to choose 12, 0 here, but either of them will work equally. Y equals a times 12 minus 6, or 6 squared, minus 302.4, and that y is going to become 0. There it is. Now I just have to solve. 0 equals 36a minus 302.4. I'm solving for the a value, which again Desmos can do, but it's nice to see it mathematically. By the way, Cracked has some great Desmos resources. 36a equals 302.4. I'll divide both sides by 36. I'll get that that A is equal to 8.4. Now I can plug that value back in, and I'm going to make sure that A is positive because parabola opens upward. That's a really good sign. If it opens downward, we get a negative, a frowny face. So I know my parabola y equals 8.4 times x, which is going to be 10, right? That's what we're solving for, minus 6 squared minus 302.4. And when I do all the math, I'll get 8.4 times 4 squared, which is 16, minus 302.4. And when I get that, I'm going to find my final answer is negative 168, but that's not the answer. We're looking for the depth, and the depth is measured in positive meters. So I'm going to plug in into my typing screen positive 168, not negative 168. Be super careful. Great work and happy studying. We did it.